Hey, you guys, this is for my sixth graders. We just finished a unit and now we're starting another one. So a fresh little start. So let's look at some of the problems that you will have this week. So the two terms that we're going to talk about today are the least common multiple and greatest common factor. So just remember, multiples are large numbers and factors are small numbers. So when you have two digits like 5 and 7 and you're trying to find their least common multiple, then one great way to do that is by listing the multiples of both numbers. So for 5, we would think 5 times 1 is 5, 5 times 2 is 10, 5 times 3, 5 times 4, so on and so forth. And of course, those numbers would never end, right? And then when we think of our multiples of 7, 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. So then as soon as we have a number that is in both sets of multiples, we have our least common multiple. Now you can always get a common multiple just by multiplying together the two digits. That's obviously a common multiple, but it's not always the least common multiple. In this case, it is. The product of 5 and 7 is the least common multiple. However, for 8 and 10, a common multiple is 80, 8 times 10, but it's not the smallest multiple. So let's list our multiples of 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6. And then 10, we count by sets of 10, 10, 20, 30, and 40. So even though 80 would be a shared multiple, it's not the least common multiple. So you always want to try to get the least common multiple when possible. All right, let's do 12 and 18. So we'll do the multiples of 10 and we might need a calculator. I meant 12. And we might need a calculator for some of these. So 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5, 12 times 6, 12 times 7, so on and so forth. And then what? 108. All right, and then I don't know what the answer is, but we'll do the multiples of 18. So 18, and then that next one would be what? 36. Where's my calculator? 18 plus 18 plus 18. So the next one's 54 plus 18 is 72. Oh, there it is, 72. So 72 is the least common multiple of 12 and 18. Now, of course, if we multiply 12 and 18 to get a common multiple, that would be a really large number, right? It'd be 216. So that's why you always want to try to use the smallest multiple possible. So your least common multiple, the smallest it'll ever be is one of the two numbers. So if I said, what's the least common multiple of 2 and 4? The answer is going to be 4. 4 is the first number they both have in common, right? But the multiple will never be less than the biggest number. So multiples are large numbers. Now here we have greatest common factor. Like I said, factors are small numbers. It's a number that can be, that each of the two numbers can be divided by. So common factors are always small numbers. So what you're going to do is think of all of the factors that you get by what two numbers can you multiply to get 9? So I always start with 1 in itself. So 1 and 9. 2 is not a factor of 9, but 3 is. So it'd be 3 and 3. Now I'm not going to repeat 3. So those are the 3 factors of 9. So then I'm going to do the factors of 15. So 1 and 15. 2 is not a factor, but 3 is. 3 times 5. And then there are no other factors of 15. So I want the greatest common factor. So the greatest common factor of 15 and 9 is 3. So 3 is the biggest number I could divide 9 and 15 by. All right, let's do all of our factors of 36. So we got 1 and 36. We can half 36, so half of 36 is 18. 3 goes into 36 12 times. 4 goes into 36 9 times. And then 10 is not a factor, 11 is not a factor, and then we already have 12, so we know we have them all. Okay, so when you get back up to one of the numbers you already have, you're done. Now let's think of the factors of 54. So 1 and 54. 2 and what, 27? I think so. 3 and 54 divided by 3 is 18. I don't think 4 is, right? No. 5, no, but 6 is, right? So 6 and 9. 6 and 9. 10 isn't, 11 isn't, 12 isn't, 13, nope, 14. And then we get up to 18. So we're done. All right, so what's the biggest number that you see on both lists? Well, the biggest common factor is 18. They have a lot of common factors, right? 9, 3, 2, 1, but 18 is the greatest common factor. Okay. All right. And so that takes us to our last pair. So the factors of 23, well, 23 is a composite number, which means, or no, it's not, it's a prime number. It only has 2 factors, 1 and itself. So that's what a prime number is. A composite number, which is what all these are, have more than those 2 factors. Now 50 does have, you know, more than definitely 2 factors. So 1 in itself, and then 2 and 25, not 3, but 4, nope, but 5, 5 and 10. And then I'm pretty sure that's all. Pretty sure that's all. But anyway, so the only factor that they both have in common is 1. And sometimes you'll get that, especially if one of them is a prime number. And that is the greatest common factor, 1. So can I divide 23 and 50 by 1? Yes, but really it doesn't help me because 23 divided by 1 is 23 and 50 divided by 1 is 50. So anyway, so that's how you do greatest common factor and least common multiple. All right, now probably you've used the distributive property again, but this section just kind of teaches it so that you can look at equivalent expressions. So if I'm going to use the distributive property, that means there's nothing between a number and parentheses. If there was a plus here, this is obviously not going to be the distributive property, right? But since I don't have an operation symbol, this is telling me I have to multiply everything in the parentheses by 7. So 7 times 4 is 28. And 7 times 9 is 63. So basically, I'm just showing you that this expression and this expression are equal. They're both equal to, what would that be, 91? All right, here we don't have an operation sign there. That means we're going to multiply everything in the parentheses times 4, both terms, not just the first one, but both of them. So 4 times 3 is 12. And 4 times 5 is 20. So these are both equal. They both equal 32. So that takes us to this question. Which expression is equivalent to this? Well, if I look at these numbers, I could think, okay, what could I divide 24 and 32 by? Well, if I look at my choices, I know I can't divide them both by 7. I could divide 24 by 12, but not 32. So that tells me that I should check the number 4. Can I divide 24 by 4 and 32 by 4? Yes. So if I divide both of those by 4, what would be left? What's 24 divided by 4? 6. And what's 32 divided by 4? It would be 8. So that's why C is the correct answer. C is equivalent to that expression. They're both equal to 56. All right, so then you guys you were introduced this week to positive and negative numbers. So if you have a number line, you can draw a number line however you want, but it's easy to see that 0 is in the center of this one. And all positive numbers are going to be to the right of 0. And that means all the numbers to the left of 0 are negative. But it's still true that the farther right you go on a number line, the numbers get bigger. So think about temperature. If it were -5 degrees outside, it would be colder at -5 than -1 because -1 is bigger or greater than -5. So it's like these are the opposite of positive numbers, right? -10 is less than -2. Obviously, positive 10 is greater than positive 2, but since they're both negative, it's the opposite. -10 is less than -2 because -2 is to the right of -10. The farther right you go on a number line, the numbers get bigger. Now, if you have negative temperatures, that represents numbers that are below 0 on a thermometer. Now, here in Georgia, we don't get a ton of days where the temperature dips below 0, right? That doesn't happen very often at all. But if you live, somewhere in the north, it wouldn't be uncommon to have temperatures in the negative range of the thermometer. So if you have numbers if you have temperatures on a day that's very cold and you say that it's below 0, the way you would show that temperature is a negative number. So -12 is very, very cold. -12 is less than if it were +2, right? And on the number line up here, we would know that -12 is to the left of +2, or the +2 is to the right of -12. Also, if you've heard people talk about elevation, they'll talk about either at ground level or sea level. So either you're going to be above sea level or below sea level. So if you're talking about something that's below sea level, that number is going to be represented by a negative number. So if you have a submarine down here, you guys, I should be an artiste. If you have a submarine at, 50 feet below sea level, we would write that as -50 feet below sea level. And then we would have an incredibly real looking airplane. Look at that, you guys. I'm not kidding. Look at that. Look at that. Crazy, right? I'm so good. All right, so let's say if we have an airplane that's up here flying at, 300 feet above sea level, how far apart is this airplane from the submarine? How far apart are they? Well, they would be 350 feet apart, right? Because one's a positive number and one's a negative number. So from 300, you'd have to go all the way down to 0, drop 300 feet, and then you'd have to go 50 more down below sea level. All right, so let's look at this math problem. It says an elevator 1 moved up 10 feet from ground level. So this is ground level, we would consider 0. It moved up 10 feet, so positive 10 feet. Its position is labeled as positive 10. Elevator 2 moved from ground level down to 5 feet below ground level. So basically it went in the basement, correct? So if this elevator moved 5 feet below ground level, down from ground level, so below ground level, what would we call that number? What kind of number would it be represented as? It would be a negative, right? -5, which the basement would be more than 5 feet below ground level, but anyway, we just went with it. Now, here's some definitions for you. You need to be familiar with these terms. If we're talking about integers, we're talking about whole numbers. Now, whole numbers are numbers you use when you started counting as a baby, right? Well, not a baby, and 0 is counted as an integer, and you didn't start with 0, you always started with 1. But whole numbers are, you know, not decimals and not fractions. So 1, 2, 3, 4, 5. And all of those numbers opposites. So -1, -2, -5, -10. And integers include the number 0. All right, so those are integers, whole numbers, they're opposites, and 0. Now, rational numbers include all integers, so all integers are rational numbers, but it also includes fractions like 1/2, 7/5, even negative fractions, -4/3, whatever, or 3/4. Negative fractions are included there. And decimals that do one of two things. Either they stop like 0.5 or 0.56, or they repeat in a pattern like 0.33333, because repeating decimals we can always write in fraction form. All repeating decimals are numbers we can write as a fraction. Even two numbers that repeat, 0.42, 42, 42. If they repeat in a pattern, it's a rational number. However, if we have a number like pi that doesn't stop and doesn't repeat, so 3.14159, and the numbers never repeat and they never stop, that would be an irrational number. So this is what pi is. So decimals count that either stop or repeat. Those are all rational numbers. And then, of course, we know that opposite numbers are two numbers, two different numbers that are the same distance from 0, like -4 and +4. Both of those numbers are 4 spaces from 0 in the opposite direction, right? So what's the opposite of 10? -10. What's the opposite of 20? -20. All right, now an opposite of a negative number is a positive number. So if that thing right there wasn't there, we'd say this is the value of this is -3.7. But then you'd have to say, well, actually the opposite of that is, the opposite of -3.7 is +3.7. The opposite of -7 is +7. The opposite of -1/2 is +1/2. So you do need to know that, especially as we start adding and subtracting fractions, you do need to always know that the opposite of any negative number is positive. You will see that again, I promise. So this question is going to come up. You will see this question soon. Which of the following statements best describes the location of the opposite of -5 on a number line? So think about a number line. Where is the location of the opposite of -5? Is it 5 units to the left of 5? Well, here's 5. 5 units to the left. 1, 2, 3, 4, 5. This is the opposite of -5. This is 4, 3, 2, 1. Actually, that's going to be 0, isn't it? Is it 5 units to the left of 0? Is it 5 units to the left of 0? Well, 1, 2, 3, 4, 5. What is this number? Is this worth -5? Is that the right answer? No, because what is the opposite of -5? It's actually +5, isn't it? Is it 5 units to the right of 0? So if this is our starting place, if we move 5 to the right, 1, 2, 3, 4, 5, is that the location? Yes, of course it is. So C is the right answer. D is not correct. D would actually be worth +10, right? All right, you guys, I think that's it. So not too difficult this week. Pretty simple lessons for you, thankfully, because you guys have had some tough ones the last few weeks. So make sure you get all your lessons done this week. No zeros. And we will probably Zoom what? I don't know. I haven't decided yet. I'll post it. All right, so make sure you look out for that. All right, if you need me, let me know. Everybody have a great week.